Hey guys, so we're going to finish up lesson 4.5. I'm going to try to do it quickly because I know the last lesson was quite lengthy. So let me present my screen. We just have a few questions to get through today, and then you'll be on your way. All right, so we're starting with problem number 11. According to the rational roots theorem, which I read the rational roots theorem to you in the previous lesson, but now you're going to actually get to see how it's applied. So the rational roots theorem allows us to come up with possible solutions to this polynomial function, okay? So the rational roots theorem uses P and Q, two little letters, where we're going to list all of the factors of the lead coefficient and then list all of the factors of the constant and set them up as little fractions, ratios. All right. So, sorry, I'm on the wrong page in my notebook. All right. So we're going to do P over Q, which instead of P, you might want to think of it as factors of constant over the factors of lead coefficient. Okay, so the constant is 7. The only factors of 7 are 1 and 7. Okay, the lead coefficient is 2. The only factors of 2 are 1 and 2. So I have to take each factor of the constant and put it over each factor of the lead coefficient. So 1 over 1, 1 over 2. 1 over 1, 1 over 2. Then the next constant factor is 7, and that has to go over each factor of the lead coefficient. So 7 over 1, 7 over 2. 7 over 1, 7 over 2. So when you're asked which is not a possible solution of the equation, well, these are the possible solutions. Not that they are all solutions, but they're possible. So 1 is a possible solution, 1/2 is a possible solution, 7 is a possible solution, and 7/2 is a possible solution. So we said 1 is a possible, 7 is a possible, so that's not going to be the non-solution. Am I missing some? No. Oh, I'm sorry. I forgot the whole plus minus part. That's kind of important. This is plus minus, by the way. So plus minus 1, plus minus 2, plus minus 7, and plus minus 7 over 2, which I'm noticing here they have it in decimal form. So we might want to write ours in decimal form. So plus minus 1, plus minus 0.5, plus minus 7, and plus minus 3.5. All right, so this is a solution. This is a possible solution. This is a possible solution. So the only one that's not a possible solution, because that's what they're asking for this problem, the one and only non-possible solution would be 2. Okay, these are all of your possible solutions, possible root, possible x-intercepts. All right, now the reason we need to know that is for the next problem. So let's go down to the next one. Find all the real zeros of the function f of x equals 3x to the fourth plus 11x cubed minus 40x squared minus 132x plus 48. Now here's the problem. We can't just set this equal to 0 and factor it, right? There's 1, 2, 3, 4, 5 terms. We've only ever factored polynomials with 4 terms by grouping, right? So we need a new way of finding the zeros, and we're going to use the rational roots theorem to help us figure it out, and synthetic division. So the first step for this problem is to find the possible solutions. So step 1, use rational roots theorem, RRT, rational roots theorem, to find possible solutions. All right, so that's that whole P over Q thing, the factors of the constant. Well, the constant is 48, so the factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Those are all the factors of 48. And then over the factors of the lead coefficient, which is 3. So that's easy, 1 and 3. So my possible solutions are plus minus 1 over 1, 2 over 1, 3 over 1, 4 over 1, right? They all have to go over 1. So 1 over 1 plus minus 2 over 1 plus minus 3 over 1 plus minus 4 over 1 plus minus 6 over 1 plus minus 8 over 1 plus minus 12 over 1 plus minus 16 over 1 plus minus 24 over 1 and plus minus 48 over 1. Now I have to do 1 over 3, 2 over 3. Okay, so plus minus 1 over 3 plus minus 2 over 3. Now the next one, 3 over 3, that's equivalent to 1, so I'm not going to write that again. 4 over 3, so plus minus 4 over 3. Then I'd have 6 over 3, but 6 over 3 is the same thing as 2, so I'm not going to write that again. So then I have 8 over 3. Then I have 12 over 3, but that's equivalent to 4. Then I have 16 over 3. 24 over 3, that's equivalent to 6. I'm not going to write that. And then plus minus 48 over 3. Oh, I forgot 20. Sorry. 48 over 3. No, that's right. 48 over 3. What am I thinking? 3. There we go. All right. So, what am I doing next? Okay, so yeah, that's step 1. Those are all the possible solutions. Step 2, and of course I didn't leave myself enough room. I have to erase some stuff in a minute, but I'll just go over here for the time being. Step 2 is you're going to test a possible solution. Now, this is where it could take a long time, right? When I say test a possible solution, what I mean by that is pick one of these and do synthetic division with the polynomial function to see if you get 0 as a remainder. Because if you get 0 as a remainder, that means it's a root. But that could take a long time. So what you're actually going to do is you're going to take your calculator, all right, and you're going to graph the given polynomial function. So I'm going to graph, I'm going to have to erase these. Hopefully you guys have them copied down. I don't have enough room on my screen to do what I need to do. Okay, so I'm going to graph 3x to the 4th plus 11x, oops, that's still up in to the 4th. Get out of it. Plus 11x to the 3rd minus 40x squared minus 132x plus 48. All right, I'm going to hit graph. Oh, I could change my window to standard so it looks like, oops, zoom to standard so it looks like yours. Okay, so I can kind of see where the graph goes through, right, the x-axis. I could also hit second table, and I'm looking for coordinates where the y value is a 0. So I can like scroll up until I find a y value that's 0, like this one, -4, 0, okay? I could keep on scrolling, see if there's anything else, and they all seem like they're getting big. Let's come down here. No good ones. I'm just going to stick with that one coordinate. All right, so -4, 0. When x is -4, I get 0 as my y value. So step 2 is to test a possible solution. Well, on that long list, -4 was one of my possible solutions. So I'm going to put -4 here. I'm going to do synthetic division. So I have 3, 11, -40, -132, and 48. So I'm going to drop the 3. That gives me -12. I'm going to add to get -1. I'm multiply to get a 4, add to get a negative 36, multiply to get a positive 144, add to get 12, multiply to get a negative 48, add to get a 0 as my remainder. So what that means is that negative 4 is a solution. So if negative 4 is a solution, so, oh my goodness, I can't spell. If negative 4 is a solution, then what is the binomial factor that was set equal to 0 that when I solved, I got negative 4 as the answer? X plus 4, right? If I put x plus 4, if I set it equal to 0, doesn't that give me x is equal to negative 4, which is my solution, right? So that's important because if that is one of the factors, the other factor is what I get from synthetic division. So my other factor is 3x to the third, right? My coefficient's 3, 1 degree less, then negative 1x squared, then negative 36x, then positive 12. Okay, from there, step 3, you're going to factor completely and solve. So if this polynomial that's left over can be factored by hand, that's what we're going to do. I'm going to try to factor by grouping, I should say. So I'm going to group the first two terms together. And I'm going to group the second two terms together. So copy that down again. My GCF here is an x squared. So I have x squared factored out. That's going to leave me with 3x minus 1. My GCF here is going to be a negative 12. I factor that out. I'm left with 3x minus 1. All right. Then my common binomial factor is the 3x minus 1. So I still have the x plus 4. That's one of the factors. Now I have a 3x minus 1. Then I have an x squared minus 12. All right, completely factored, and completely factored. Okay, so it says find all the real zeros of a function. So that just means now I need to set each of them equal to 0 and solve. So 3x minus 1 equals 0, and x squared minus 12 equals 0. So I have x is equal to negative 4. I have x is equal, I'd add the 1, divide by 3, so that's 1/3. And then I'm going to move the 12 over by adding it. And then I have to take the square root. Don't forget your plus minus. I have to simplify that square root to 2 root 3. So here's two solutions. Oops. Here's one solution, and here's one solution. Total 4 solutions for my 4th degree polynomial. All right. Okay. I know that was a lot. Okay, for the next one, it says, actually, you know what? I'm going to jump down. I'm probably going to have to come back to those. Let's do number 14, and then we'll see what time we have left, because I have to go in 6 minutes. Shh, go in the other room. Shh, shh, shh. All right, so use the information in the graph to answer the question. What are the real zeros of the function? Okay, so the real zeros are the ones, oops, my pen, x-intercepts, which are -6 and 0, right? So your x-intercepts are the real zeros, which are x equals -6 and x equals 0. It says write an equation of the cubic function in factored form. Now notice that we passed through this one, but we touched. So that kind of tells me something about the degree, right? So if x equals 6 is a solution, that means the binomial factor that I set equal to 0 to get x equals -6 was x plus 6. And then if x equals 0 is a solution, that just means that there is a GCF of an x pulled out. And I set that equal to 0 when it was in factored form. But since I just touch here, right, that tells me that it has an even degree. So it would be x squared times x plus 6. That is your function. Now that's your function in factored form. If you wanted to see that it was cubic, you distribute that x squared back in to get x cubed plus 6x squared, okay? So either one of these is fine, just depends if you want to see it in factored form or all multiplied out together. All right, that one was pretty fast, so I do have time to go back up to the other ones. Okay, so I'm probably just going to do 2 of these. It says, write a polynomial function of least degree that has rational coefficients and a leading coefficient of 1 and the following zeros. So there's a hard way of doing these problems and an easy way of doing these problems. The easy way is using what we call the sum and product rule, which is how I'm going to teach it. All right, sum and product rule. So again, if -5 is a solution, that means that the factor x plus 5 is one of the binomial factors of the polynomial, because if I set that equal to 0, I get x is equal to 5. Okay, so that one's easy. Now, if x plus root 2 is a solution, that also means that x minus root 2 is a solution. Okay, and that's because think about if you have plus a radical, then at some point you took the square root of both sides and you would have had the plus minus. Okay, so this is what you're going to do the sum and product rule with. You're going to take those two and find the sum. So you're going to have 4 plus root 2 plus 4 minus root 2. When you add common terms together, like terms together, you're left with a sum of 8. Then you're going to find the product of those two. So the product of 4 plus root 2 and 4 minus root 2. So when you FOIL, 4 times 4 is 16. 4 times negative root 2 is negative 4 root 2. Root 2 times 4 is positive 4 root 2. And root 2 times negative root 2 is negative root 4. So the middle terms cancel. You're left with 16 minus 2, right? Because the square root of 4 is 2, which gives you a product of 14. Okay, so the sum and product rule, you're going to then plug into x squared minus sum x plus the product. Meaning whatever the number is for the sum, you're going to put it in there. Whatever the number for the product is, you put in there. All right, so it becomes x squared minus 8x plus 14. So that is the other factor of this polynomial. So keep in mind, I have this as one factor. Can't draw straight. And this is the other. So I'm still not done. All right, I have to erase some stuff to give myself room. So what you need to do next is take your two factors. So x plus 5 is one factor. And I'm going to write this one right next to it. So I have x squared minus 8x plus 14. And the final step, so that you can be done with this problem, is to multiply it all together and get a polynomial function of least degree, rational coefficients, leading coefficient of 1, and the following zeros. So distribute the x into all of it. So I have x cubed minus 8x squared plus 14x. Distribute the 5 into it, so plus 5x squared minus 40x, and then plus, what is that, 70. Okay, combine like terms. So negative 8 plus a 5 is a negative 3x squared. A 14x and a negative 40 leaves you with a negative 26x, and then plus 70. Since we want a function, we write f of x equals x to the third minus 3x squared minus 26x plus 70. So this is the polynomial function of least degree, rational coefficients, leading coefficient of 1 that has these following zeros as solutions. Okay? And we'll do more examples of this in class for sure, right? But that's all I'm going to do this evening. I'm trying to keep the video on the shorter end since your last one was long. All right, so I will see you guys back here for this video lesson. Bye.